Kubernetes namespaces and annotations. In the world of Kubernetes, namespaces are a powerful way to organize and isolate resources within a cluster. Imagine you're managing a large apartment complex. Namespaces act like separate buildings in that complex, each with its own tenants, rooms, and utilities. This helps ensure that the tenants of one building don't accidentally interfere with another. When you first install Kubernetes, it comes with a few default namespaces. These include default, where your workloads run unless specified otherwise, kube system, which is reserved for internal Kubernetes components like the kube DNS or the kube proxy, and kube public, which holds resources that should be visible across the cluster, even to unauthenticated users. There's also kube node lease, which is used to track the health of nodes with heartbeat signals. These initial namespaces are crucial to the functioning of Kubernetes and serve as the foundational layers of organization in your cluster. Working with namespaces is straightforward. You can create a new namespace using a simple kubectl create namespace command. Once created, any resource, such as pods, services, or config maps, can be assigned to that namespace. This makes it easier to manage access, apply limits, and clean up environments. For example, in a development team, you might assign a separate namespace to each developer or project, isolating their workloads from one another. When using kubectl, you can specify the namespace with the namespace flag. Or, you can set a default namespace context so you don't have to specify it each time. Namespaces are also useful in multi-tenant environments, where multiple teams or customers share the same Kubernetes cluster. In such cases, namespaces provide a level of logical separation that enhances both security and organization. Namespaces also play an important role in DNS resolution within the cluster. Kubernetes services are assigned fully qualified domain names that include the namespace as part of the address. For example, a service called myService in the dev namespace would have a DNS name like myservice.dev.svc.cluster.local. This naming structure ensures that services with the same name in different namespaces won't conflict and can coexist peacefully. Now let's talk about annotations. Annotations in Kubernetes are like sticky notes you attach to objects. They don't affect how the object works, but they store useful information that tools and users can use. While labels are used for identifying and selecting objects, annotations are meant for attaching metadata that's not meant to be used for selection. For example, an annotation might hold the last time a configuration was applied, or a pointer to documentation. You can add annotations to almost any Kubernetes object, pods, services, deployments, and so on. They're especially handy for automation tools, monitoring systems, or custom scripts. For instance, an annotation could be used to tell a monitoring tool how to handle a specific pod, or indicate who deployed a resource and when. Understanding namespaces and annotations helps you write better, more organized, and more scalable Kubernetes configurations. With these tools, you gain control over the complexity of managing applications at scale. Field selectors in Kubernetes are a way to filter Kubernetes resources based on the values of specific resource fields, such as the resource's name, status, or metadata. They are especially useful when you want to list or watch resources that match specific criteria. Field selectors, unlike label selectors, which filter resources based on custom key value pairs added by users, field selectors filter based on built-in fields that Kubernetes assigns to objects. For example, you might want to list all pods running on a specific node, or all pods that are in a running phase. Common use cases. Get all pods running on a specific node. Find all pods in a certain phase, for example, running, pending filter by pod name. Filter by namespace, when using from a different namespace. Examples. Get all pods in the running phase. Kubectl get pods field selector equals status.phase equals running. Get all pods scheduled on a specific node. Kubectl get pods field selector equals spec.nodename equals myNodeName. Get a pod by its exact name. Kubectl get pods field selector equals metadata.name equals mypod. Get all events related to a specific involved object. Kubectl get events field selector equals involved object.name equals mypod. Field selectors can be combined with label selectors, but only in logic is supported, not OR. Supported fields. Field selectors vary by resource type. Some common fields include metadata.name, metadata.namespace, status.phase, spec.nodename. You can view all field paths for a resource by outputting it as JSON and examining the structure. Kubectl get pod mypod.json. Limitations. Field selectors only support exact matches, not partial matches or wildcards. No OR logic or complex Boolean expressions, only in conditions. You can't filter on arbitrary nested fields, only whitelisted fields are available. Field selectors are used in Kubectl to filter resources based on built-in fields like name, phase, or node assignment. They're perfect for scripting and diagnostics when labels aren't available or useful. In Kubernetes, finalizers are a special mechanism used to ensure that specific cleanup actions are completed before a resource is permanently deleted. When a Kubernetes object, such as a pod, custom resource, or namespace, is marked for deletion, Kubernetes doesn't remove it immediately if it has one or more finalizers listed in its metadata. Instead, the resource enters a terminating state. The idea behind finalizers is to give controllers or custom processes a chance to perform cleanup tasks. For example, if a resource created some external infrastructure, like a cloud database or a load balancer, a finalizer can pause deletion until those external resources are properly removed. This prevents resource leaks and ensures that the system remains clean and consistent. Finalizers are defined in the metadata.finalizers field of a resource. When you add a finalizer, you're telling Kubernetes, don't delete this until I say it's safe. Once your cleanup logic completes, your controller or script must remove the finalizer from the object. Only then will Kubernetes proceed to actually delete the resource. It's important to manage finalizers carefully. If a finalizer is never removed, say, because the controller responsible for it crashes or is misconfigured, the resource will remain in a terminating state indefinitely. This is sometimes referred to as a stuck resource. Operators often need to intervene manually in such cases, typically by editing the resource and removing the finalizer entry. Finalizers are especially useful in custom controllers and operators, allowing developers to extend Kubernetes behavior with safe, orderly cleanup of associated resources outside the cluster. They play a key role in managing lifecycle hooks and keeping resource dependencies in sync across systems.